Welcome back all. Today we're going to construct a helper header. Now this particular header will be a file where we will pretty much dump and place all the functions, types, and other things which we, in a logical sense, cannot fit really anywhere else. I mean, in a technical sense, we generally could, but it doesn't make any sense. So we're just going to dump them into the helper header, where we're going to use these basically helper things. They are there to help us out with certain other functionalities. Also, there will also be some redundant assets in this helper header where, I mean, we're not going to use them immediately. Most likely we are going to use them later on, but believe me, it is better to have them there now than later on to come back and write them, although that's generally the way it's done. But let's go ahead and finish our helper header, which in all likelihood we will modify at some later point in time once we add more functionalities to it. So as before, just go ahead and click on File, New, Empty File, Yes, and we're going to name this helper.h. Is it named helper.h? It is. Save. Okay. Let's zoom it in so that we can all see what is going on, and let's begin writing our guard for this header. Still didn't change the keyboard. God. I think I will change it in the follow-up tutorial. I will have to do it, otherwise I will go insane. If and def helper underline h. Now, I've explained what guards are in the previous tutorials, but just to add to this, this particular name where it says helper underline h, basically this is up to you. But this is some sort of a standard, and the name does need to be unique, so be very careful with that. Okay, excellent. It gives me the closing ones, so let's just continue. Define helper underline h, and let's begin writing our code. The very first thing that we will need to do is write a series of include statements. Include, so we will definitely need ctime, because we will use the helper header to retrieve time and to be able to orientate our program in terms of mail sending triggers and so on. So we will need some sort of time, definitely. Let's go ahead and type in include also string. Now we will use it we will basically use it for converting various types to string, because we will use strings in order to fill out our log files. So the keystrokes on the keyboard, other function keys, except the characters on the keyboard, other function keys, etc. We will basically be converting all of that to strings and then sending it off to a log file. Making some hand gestures over here, maybe you can hear them. But anyway. Please, there we go. Include stream. So this is the one that we'll actually be using for converting the string. Is there just because we need a string. We will be doing some operations with strings, but stream will be the one used for converting various types to strings. Got a little bit confused there. Okay, so next up, we will go ahead and create our own namespace in order to group functions, types, and onwards. This is why it is important for you to use later on, and as I have used in the previous code, like this std, this is a namespace, and then I type in string. But if I typed in using namespace std, like this, I would never again need to type in std string within this file. However, the above is not a good practice in general. The below is far better, because once we construct our own namespace, which will be called helper, it too might contain a custom type string. So yeah, it's going to give out errors later on. You're going to have problems, etc. So if you type in string like this later on, this might cause problems without the std, etc. So later on, we will simply use helper : and this is how we will actually refer to the string. I'm just using string as an example here. We're not actually going to create a custom type string, but we will create some custom types of our own. So let's just go ahead and delete this. I just wanted to explain it. Let's begin. Namespace helper. Now, this will be our own header, our own namespace to group functions, etc. Okay, thank you CodeBlocks for finishing this up for me. Now let's go ahead and create a template. So yes, my typing skills. Feel free to laugh, it's all welcomed. To an extent, please. Don't take my word for it. Anyway, we will use it to create functions which will accept generic types. So in essence, pretty much, it will accept, these sort of functions will accept pretty much anything. Instead of class T, we can also use type name T. So if you find it somewhere on the net, it's pretty much the same thing. Let's go ahead and create our first prototype of a function. So std : string to string, and now we shall type in const t and percent. No, yes. Oh my god, is it here? Yes, it is. There we go. Const t and %sign. Now this is a prototype of a function, and that is only stated here, but down below we will actually formulate the body of a function. All functions, types, classes, variables, and so on have to be stated in a form of a prototype or implemented before we can actually use them. This is the case for C++, but this is not the case for C# and Java. I don't really like C#, but oh well. Java, something. So we will use this particular function in order to convert pretty much anything to a string to be later used to fill our log file. Function accepts T, some sort of a T generic type with a reference to constant type to avoid copying. So there won't be any copying of variables, we'll just be using the addresses. And pretty much, keep in mind, pretty much, whatever we pass to it will be converted to a string. So if we, for example, later on first decide to use it, and if we type into string, and I do this 5, this will be number 5, which is an integer, will be converted to a string. I'll just go ahead and delete that. That's going to be quite useful later on because we'll get a lot of characters and we will want it to be a string so that we can actually put it into our log file with great ease. And let's say that you give an integer and a floating point to this function like this, so to string, and we call this function and we pass 5 as before, and then we type in, then we call it again to string and we pass, I don't know, 4.6, and so on and so forth. So the compiler itself will create a separate function for each of the types, and it will have the same body. So if you have integer, double, floating point, etc. I have an integer and a double here, but if I had like 3 of them or 4 of them or 5 different variables, 5 different variable types, the compiler would create 5 separate different functions with exactly the same body, and that's how it works. Now, another thing to keep in mind, that you should take my statement that the function will accept pretty much anything with a grain of salt, as there are some things that you won't be able to pass to this function. However, this will be explained more later on when we actually implement the function, so we're not going to bother with that now. Okay, so now we can go ahead and continue. Now we need to go ahead and create a struct datetime. So struct datetime. This is a helper struct used in order to represent date and time. Structs are user-defined types. They're pretty much like classes. Classes are new in C++, but they do not exist in standard ISO C. But structs did exist in C as well, unlike classes. The difference between struct and classes in general, well, they're not that much different to begin with. Classes are just structs with functions. Well, this is in essence anyway. The main technical difference in structs is everything is by default in public, meaning that everything is accessible from every other type, which is not really something that is always useful to us. So there are no private or protected modes, while in classes everything is by default private, meaning that it can only be accessed from that particular class, unlike structs where everything is by default public. That is why we have placed the public tags in the previous tutorial in our class, so that it can actually be accessed. Here I can show you key constants. You see it says here public. If this was private or protected, we would have problems. Anyway, let's go back to our helper.h and let us continue. So now we need another opening and closing tags, and now let's type in date, time. Okay, so this is a constructor for this particular struct that does not, that does not take a parameter, and it creates an object of date-time type with the current system time and date. By this I mean this is a local time on the machine on which the keylogger is running. This is not your machine or any other machine. This is a machine where the keylogger is running at the moment. Okay, so once again, let's go ahead and begin formulating the body. Let's type in time underline t ms semicolon. So time underline t is a type which represents time, which is located in ctime library, and ms is just the name of the variable. Ms is in milliseconds. Well, actually, we're going to use seconds, but at the time of writing this, the idea was milliseconds for some strange reason, God knows why. Probably because it was written very fast. But, oh well. It's ms. Let's just leave it at that. I really don't feel like changing the ms variable in the whole code and debugging it again to see if I've made any errors. So, once again, time underline t is a type which represents time, which is located in the ctime library, and ms is just our variable. It's just the name that we have placed there. For reasons unknown, it is ms. That's supposed to be a shortcut for milliseconds. Suppose you can blame the imagination for that. Now down below, we will use the time function. Oops. Yep, there we go. ms. Now, this is a function from ctime library. Again, you can see the ctime on top. We have included it, which takes system time and places it into a variable ms. That is why we are passing the address of the ms variable, again, to prevent a lot of copying from occurring. Okay, so, well, maybe not the copying, but in any case, we're just passing the address. My bad there. So, again, down below, we will need to go ahead and type in struct dm, and we're going to use a pointer here. Info equals local time ms. Okay, now the variable info, you can see it right here. This is a pointer to a struct dm, and that is also a type from the ctime library. Pointers are variables that contain the address, so the memory address, the address in the computer's RAM of another variable, referred to as pointee. And we can access the variable to which they point indirectly, in a sense that you can access a pointer, and in doing so, you will access the variable to which it points. We shall make the pointer info point to the return value of the function local time. So local time will receive a variable and then the address, and then it will do something with it, and then it will return a value. We will use that value and state that this pointer will point to that particular value. Okay, now we go down and we shall state that d equals info. Let's make it really neat and readable. Okay, so yeah, it's gonna look better like this. TM underline day. Now, this represents, well, D represents a day, and we will use the info pointer to indirectly access the attribute TM underline mday. You can see it here on the screen from the struct TM. D and other variables are simply the attributes of this particular struct from date time. So hello, date time, we just made you. So we are just accessing your attributes. Okay, so down below, we're gonna go for M because we're gonna need all of these, and pretty much the same rules will apply with minor differences occurring between one and the other. TM underline month plus 1. Okay, M represents a month, obviously, I think you can figure that out, and it's pretty much the same, and pretty much the same things go for it as for day or D above. But the problem is that it starts from 0, so we have to add 1 to it. Otherwise, January would be represented as a 0, which is not something we want. Next up, we need a year. So year shall be, referent year shall be 1900s, 1900 and plus info going to TM underline year. Y represents a year and will begin from the 1900. That will be our referent year. C came to be in the 70s, and a bit later came C++. Unix time began on the 1st of the 1st, 1970. And local time function will return the amount of seconds that has passed from that particular date onwards till present day. And we are just basically going to format those seconds and create a format that is bit more human-friendly, that is readable by us in an easier fashion. So we will be able to see like the day, minute, second, month, year, hour, etc. Because it would just be kind of difficult to orientate yourself just by the amount of seconds. Okay, so next up, we're going to need minutes. It's going to be info TM minute. H shall equal to info going into TM hour, and we will need S for seconds. This is ugly. This shall go into TM underline sec. Okay, so that'll be it. These are just same things apply for minutes, hours, and seconds as I've explained for days, months, and day, month, and year. We're just doing the same thing repeatedly over. Now I'm running a little bit short on time, so I'm going to cut the tutorial here, and I'll continue in the follow-up.